In this problem, we have the number x in thousands of cat flea collars demanded each year when the price of a collar is p dollars is expressed by this function x cubed plus 225p squared equals 19,000. So the collars are currently selling for $4 each, and the annual number of sales is 24,879. What we want to find is the approximate decrease in sales of the collar if the price of each collar is raised by $2. Now, the word approximate here is important because that implies that we're finding the marginal sales. We're going to use the marginal sales in order to approximate the decrease in sales. And that's from the word approximate. That's how we know. Okay, so the number x of cat flea collars demanded each year when the price of a collar is p. What that tells us is that x is a function of p, or x depends on p, okay, price p. So we're dealing with a function of the form, x of p. When we find the derivative, we're going to be finding dx dp because x depends on p, price p. The number of sales depends on the price. So we're given some current numbers. We're not going to really need those until the end when we get to the marginals, then we'll plug in the numbers. But first, in order to use marginal sales, we need to find the derivative of sales, right? The derivative of x with respect to p. Then we'll plug in the numbers and do the calculation. Well, in order to find dx dp, there's two ways. You could first solve for x, but then you're going to have a cubed root of something kind of messy. So instead, I'm going to use implicit differentiation in this problem by differentiating both sides of the problem. So we're going to take the derivative of the left. So the derivative of the left side is x cubed plus 225p squared equals the derivative of the right side. So when you take implicit differentiation, you take the derivative of each entire side. Now, the derivative of x cubed. Normally, in most problems, it would just be 3x squared. But because x is a function of p, x is now the dependent variable. It's like your y. So this is really a chain rule derivative because we have a function all being cubed. So we're going to bring the 3 down, times the inside function to the power of 2, times dx dp by the chain rule. We're differentiating that inside function. Plus 225 times 2 is 450 p to the first. And there is no dp, d anything, because p is like your x usually. It's the independent variable. And then the derivative of 19,000 is 0. Okay, now we need to solve for dx dp. So 3x squared times dx dp equals negative 450p. And then we divide both sides by 3x squared to get dx dp by itself. So we get negative 450p over 3x squared. Okay, and that's the general derivative that tells the rate of change of sales with respect to the price. So if we want to find the approximate decrease in sales if the price is raised by $2, well, first we'll find the approximate decrease in sales if the price is raised by $1, and then we'll double that. Okay, so let's write that out. So the approximate decrease in sales if p increases by 1 is given by dx dp. Okay, so we need to plug in our numbers then. We need to plug in 4 for p, and since x is in thousands, we'll actually plug in 24.879 right there. So we'll have, let's see, dx dp when, let's see, x is 4 in this problem when x is 4. And P, no, I got that backwards. When the price is 4, I'm writing D, yeah, that's right, dx dp. When price is 4 and sales are 24, or x is 24.879, is, okay, we're plugging in to the derivative here. I'm just plugging in numbers. So negative 450 times the price is 4, all divided by 3x squared, so 3 times 24.89, oh, 879, I reversed that right there, 879, if you look up here, squared, 24.879 is squared. So we're going to need a calculator here to approximate that. Let's clear that out. Oops, restart my calculator. Okay, so we have negative 450 times 4 in the numerator, divided by, now we need parentheses to include all of that in the denominator, 3 times 24.879 squared is, okay, negative, let's carry this out in multiple decimals here, negative 969,361. 969,361. Double check that I wrote that correctly. 969,361. Yes, okay. Now that's in thousands. That's the decrease in sales in thousands, since that's our unit on x, per increase in dollars. So if x goes up by 1, if I entered that correctly, it does look like I did. When x goes up by 1, yeah, sales drop by this many thousand, which is really, so it's moved the decimal over 3 places. So sales drop by 969.36 units. Okay, so approximately, sales are going to drop 969, if you round down, 969 units. Okay, but we're interested in what is the approximate decrease in sales if the price of the collar is raised by $2. Well, this is the approximate decrease in sales if P increases by 1. Okay, that's, right, if you round down. But we want to know what's the approximate decrease in sales if P goes up by 2. So we're going to double that. Okay, so therefore the approximate, I'm going to approximate my words here, the approximate decrease in sales is 2 times that answer. Now, notice if we multiply 0.969361 times 2, we're going to get a slightly different answer than if we multiply negative 969 by 2, because the 3 round up. So I'm going to use the unrounded version here. 70 times 2. Let's go back over to my calculator. Put times 2. So we get negative 1.93. If you round that up, negative 1.938. Well, I'll just write it out. Negative 1.9387. Negative, what did I say that was? 1.9387. Okay, move your decimal over 3 places. So it looks like sales will decrease by negative 1,000. Hard to read. Let's try a different color. Negative 1,930, depending on how you round. Okay, 39. I'm going to round up units. If you had taken this rounded number and multiplied that times 2, 969 times 2 is negative 1,938. So as far as which one the computer system is going to accept, you'll just have to try one and then try the other. depending on if you round that version or